Let's talk about that constant battle in tech, right? The push to move fast and ship new stuff versus the absolute terror of breaking things. Well, Site Reliability Engineering, or SRE, gives us a way out of that fight. Today, we're going to break down the framework that turns those heated arguments into calm, data-driven decisions about what reliable enough actually means.
So, here's our game plan. We're going to start with the fundamental problem SRE was created to solve. Then, we'll build the solution, piece by piece, figuring out what to measure, how to set a target, and then we get to the most powerful concept of all, the error budget. And if you stick around, you'll see how it all clicks together into a toolkit you can actually use. All right, let's dive right in. At the very heart of pretty much every tech company is this deep, nagging conflict, moving fast versus staying stable.
You know the scene. The development team is trying to push out cool new features as fast as they can. That's how you innovate, right? But then you've got the operations team, whose job is to keep the lights on. And for them, every single new release is a potential disaster. For ages, these two goals have been in a constant tug of war. SRE is what finally gives us a way to solve this with cold, hard data.
And the solution, which famously came out of Google, is SRE. I love this definition. It's basically about reframing the whole problem. You take software engineering principles, like data, automation, and really precise measurement, and you apply them to the world of operations. Suddenly, that old shouting match becomes a structured, data-driven conversation. So, how in the world does SRE pull this off? Well, the entire foundation is built on one thing, measurement. But, and this is key, it's not about measuring everything under the sun. It's about measuring what actually matters to your users. The very first building block is the Service Level Indicator, or SLI. The best way to think about an SLI is as a super precise question about your service's health that can only be answered with a number. And it's always a simple ratio, the number of good things that happened divided by the total number of things that happened. It's clean, simple, and you can't argue with it.
Now, this is a really important distinction. Let's be honest, your users couldn't care less about your server's CPU load. What they care about is whether the page loaded fast enough or if their payment actually went through. A good SLI always measures the world from the user's point of view. It directly connects the work you're doing to their happiness.
And that brings us to this core principle. Before you even think about writing a single line of monitoring code, you have to stop and ask, what does good even mean to our users? They're the only ones who can answer that. See, reliability isn't some abstract technical thing. It's just a measure of whether you're actually meeting their expectations. Okay, next up, setting your target. So once you have your SLI, your way of measuring reliability, you need to set a goal. How good is good enough? That target is your Service Level Objective, or SLO. It takes that SLI we just talked about and attaches a specific goal and a time frame to it. So for example, 99.9% of all our API requests will succeed over a rolling 30-day period. That becomes your internal promise. It's the line in the sand your team commits to hitting. It is so important to understand what these percentages actually mean in the real world. Chasing another 9 of reliability isn't just a number on a page. It translates directly into how much downtime you're allowed to have. Just look at the jump from 3 nines to 4 nines. You go from almost 9 hours of downtime a year to less than an hour. That leap is incredibly difficult and expensive to make.
Just let that sink in for a second. 52.6 minutes. That's your total entire allowance for things being broken for an entire year. That includes planned maintenance, bugs, outages, everything. Committing to a 4 nines SLO is a massive engineering challenge. It completely changes how you build and release your software.
Oh, and a quick but super important note, do not confuse an SLO with an SLA, a service level agreement. Your SLO is your internal goal. The SLA is that external promise you make to a customer, usually with financial penalties if you break it. Your SLO should always be stricter than your SLA. That creates a safety buffer so you can fix problems before they breach a contract and start costing you real money. All right, now we get to what I think is the most powerful and transformative idea in all of SRE. This is where we take everything we've just discussed and turn it into a practical decision-making engine where risk finally meets reward.
So if your availability SLO is 99.9%, then what about that leftover 0.1%? Well, that is your error budget. The math is dead simple, but the implication is huge. SRE basically says, look, 100% reliability is impossible and a waste of time. So instead of chasing perfection, it creates a specific agreed-upon budget for imperfection.
And here is the crucial mental shift. That 0.1% isn't a failure budget. You have to start thinking of it as your innovation budget. It's the currency you spend to take risks, like launching a brand new feature or running a wild experiment. Every change you make might spend some of that budget, and that's not just okay, it is expected.
This is how you finally break that stalemate between development and operations. The error budget gives you an objective, data-driven answer to the question, hey, can we release this new feature? If you've got plenty of budget left for the month, the answer is yes. Go for it. Move fast. Innovate. But if your budget is all used up, the answer is a hard no. It's all hands on deck to improve reliability until that budget is healthy again. Okay, so the concepts are pretty clear, but how does this actually work day to day? Let's talk about what you should be monitoring to track those SLIs and manage that precious error budget. If you're wondering where to even start, Google gives us what they call the 4 golden signals. The idea is, for any user-facing system, if you can only measure 4 things, measure these: latency, traffic, errors, and saturation. Together, they give you a really solid, high-level view of your service's health, and they're often the perfect basis for your most important SLIs. And here's a pro move. You don't just alert when the budget is gone. That's way too late. You alert on the burn rate, how fast you're using it up. A huge spike that burns through your whole day's budget in an hour? Yeah, that needs to page an engineer right now. But a slow, steady burn that might exhaust your budget in a week? That can just generate a ticket. This is smart alerting that actually respects your engineer's time and sleep. All right, let's wrap this all up. We're going to pull everything we've talked about into a simple, actionable workflow. Your own SRE toolkit. And here it is, the whole playbook from start to finish. Notice how it all begins and ends with the user. You identify their most important journeys, you define metrics from their perspective, you set targets based on what they expect, and then you use that resulting error budget to make smart, data-driven decisions about how fast you can innovate. If you take one thing away from this, let it be this. The goal of SRE is not to achieve 100% uptime. That's a fool's errand. The goal is to agree on a reliability target that is good enough, and then manage everything, your operations, your releases, your development, to hit that specific target. That discipline is what frees up all your remaining energy for innovation.
And that leaves us with one final thought. We all know our services aren't perfect, and they never will be. SRE asks us to stop treating that imperfection as a failure, and instead to measure it, to manage it, and to relabel it for what it really is: the budget we have to build whatever comes next.
We hope you enjoyed this video. Like and subscribe for more Apex Insights.